Hello and welcome guys to my YouTube channel. In this video, we will be taking a look at ratio. Now let's start with understanding what is a ratio. Now a ratio is a mathematical comparison between two or more quantities that shows the relative size of one quantity to another. Okay? And the ratio can be expressed as a fraction of a whole. Now to understand this more, we'll take a look at this case right here. Now, let's say you have a cake that is cut into 8 pieces, okay? Now, if the cake is shared between two people in the ratio 2 to 6, okay? This means that person A receives, firstly, 2 pieces of cake, and person B receives 6 pieces of cake, okay? So this is what ratio is. Okay, so as you can see, we're showing the relative size of one quantity to the other. Okay, so 2 and 6. Okay. Now, you need to understand that ratios can be scaled up by multiplying or scaled down, or otherwise known as simplified, by dividing. Okay? We call the result an equivalent ratio because the result is still relative to each other. Now, to further explain this, let's take a look at the previous example. So we had the ratio being 2 to 6. Now, if you can see a common factor between them, then I can divide all of the ratio by, for example, 2. And this gives me 1 to 3. Okay? Now, you need to understand those two ratios right here, they are equivalent. They're called equivalent ratios, okay? Because they represent the same thing. In the end, the relative size of the first part is the same relatively to the other part, okay? So in this case, what we're saying is that for every one part that the first person receives, the other person will receive 3 parts, okay? Here, for 2 parts that they receive, the other person will receive 6 parts. So technically, it's exactly the same, okay? If you have 8 pieces and you want to divide them, based on the first ratio, you're like, okay, so the first person will receive 2 pieces, and the second person will receive 6 pieces, okay? Now, if you want to divide them based on the 1 and 3 ratio, well, you have 8 pieces. So at first, the first person will take 1 piece, and the second person will take 3 pieces, okay? So for every 1 piece, the second person takes 3 pieces. But the cake is not done. Right here, you have 4 pieces. There's still 4 more to go. So then again, you will give the first person 1 piece, and the second person another 3 pieces. And now that's it. There's 0 pieces left. So how much in total did the first person receive? Well, 2 pieces. And the second person, 6 pieces. Okay? So in the end, it's exactly the same. Gives you the exact same result. Now, you can even scale up your ratio by multiplying both sides. So let's say I multiplied by 100. This will give us 200 in ratio of 600. Now, what this means is that, for example, if you have a giant cake with 800 pieces, the first person will receive 200 pieces, and the second will receive 600 pieces. Okay? So I hope this was clear. So with ratios, you can either divide or multiply. You divide to simplify. Okay? You multiply to scale up the ratio. Okay. Now, firstly, we have a required skill, which is to learn how to simplify our ratios. Okay? So let's take a look here. So for example, you have simplify, and the ratio is 4 to 10. Okay? So when you take a look here, you start thinking of common factors between the two, and we know that 2 is a common factor, so we'll go ahead and divide by 2. So this gives us 2 and 5. And that's it. This is as further as you can simplify. There's nothing else that you can divide by that will give you any less simplified form, okay? Now, simplify 30 and 10. So again, I will go ahead and write 30 and 10. And I will go ahead and divide. The highest common factor between 30 and 10 is 10. So we get 3 and 1. And that's it. The next one. Now we have 375 and 2250. Okay. Now, in order for me to be able to simplify this, sometimes the numbers are quite big, so it's not as easy to figure out a common factor. However, we do know that we want to find a factor that will divide both 375 and 2250. Now, you can use a trick by writing on the calculator 375 divided by 2250, okay? Because this will simplify as much as possible, okay? So it will give you 1 over 6, okay? Now, wait, let me just rewrite this. So what you should write on the calculator is either that division or a fraction like this, okay? So we can see that the 375 became 1 and the 2250 became 6. So how did that happen? Well, we obviously divided by 375. You can tell easily by the top part, okay? So the way to simplify this is to divide by 375, okay? And that will give you 1 and 6. That's the final answer. Now, sometimes you have cases like this where you're given a ratio, just 4 to 10, and you need to write it in the form 1 to n, okay? Where n could be any number, really. Now, here's what we do know. The first part of the ratio should become 1. So what am I supposed to divide by so that we can get 1? Oh, divide by 4. So the left over here gives us 1. And meanwhile, on the right, you can just divide 10 by 4 on the calculator and it gives you 2.5. Okay, so that means n is equal to 2.5. Here's another example right here. So we have 6 and 57 in the form 1 to n. So again, I will go ahead and divide by 6 because I know that the 6 is a 1 now in this ratio, in this equivalent ratio. So this gives us 1 on the left, and 57 divided by 6 gives you 9.5. Okay, so I hope this was clear. This is just simply to find equivalent ratios. You need to understand we actually did not change the ratios at all. They're the same. We're just simplifying them. You can think of it as a fraction, okay? When I have a fraction, you have 1 over 3, and you multiply the top and the bottom by, for example, 7, you get 7 over 21. But this is still the same fraction. Nothing changed. We just scaled it up. Or the other way around, when you divide by 3, you get 1 over 3, and it's still the same fraction. The only thing you need to be careful about is to understand that when you, for example, have a ratio 2 to 3, it is not equivalent to 2 over 3, okay? Those are not equivalent at all. Never write them this way. 2 ratio 3 is not 2 over 3, okay? We'll talk and understand more about this in later, okay? Now, let's take a look at the second required skill, which is understanding ratio as a fraction, okay? So here we go. A ratio of 1 to 3 is not equivalent to 1 over 3, which is what we just explained, basically. Okay, so it's really important to understand that. Now let's understand how does a ratio really get represented as a fraction, okay? So given that a cake was cut into 10 pieces and divided in the ratio 4 to 6, find the fraction of cake each person receives, okay? Now here's the thing. You have 10 pieces that are supposed to be divided in this ratio right here, okay? So the first person will receive 4 pieces. And the second will receive 6 pieces. Right? So if I wanted to express what the first person received as a fraction of a whole, then it would be the pieces he received divided by the entire number of possible pieces, which is 10. That is the total. Okay? If you simplify this further, this gives you 2 over 5. So we can say that the first person received 2/5 of the cake. Now the second person received 6 over 10 being the whole. Okay? Which also simplifies to 3 over 5. Okay? And so the second person, we can say that he received 3/5 of the cake. Okay, so I hope this was understood. Now, of course, we can convert the fractions into percentages as well. Okay, so for example, when we had 2 over 5, now how do I convert 2 over 5 to a percentage? I multiply by 100. Okay, and this will give you 40. And don't forget the percentage sign. So this will give you 40%, okay? So we can say that the first person received 40% of the cake, right? And the second person, I have 3 over 5, also multiplied by 100, and we get 60%. So the second person received 60% of the cake, okay? And it's really important to understand this. So this is what we mean by saying that in ratios, 1 to 3 is not 1 over 3, okay? So if we actually write the top part right here, so 1 to 3, now you need to understand, you don't need the number, the original number of cake that you're dividing by to know how much percentage will each person receive. Like for example here, how many parts do we have? We have 1 part over here and 3 parts over here. So 1 plus 3 is 4. So the total parts is equal to 4. The first person receives 1 out of those 4 parts, and the second person receives 3 out of those 4 parts, okay? So this is what the ratio is. Now, if you multiply this by 100 to get a percentage, you will get 25%. And if you multiply this by 100 to get a percentage as well, you get 75%. So what this means is that for the first person, no matter what you divide, if you had 10 pieces of cake, he will take 25% of the 10. If you had 100 pieces, he will take 25% of the 100. If you had 1,000 pieces, he will take 25% of the 1,000. And the second person will take 75%. Okay? So the ratio is relative to each other. So no matter what you're dividing amongst people, this person will always receive 25% of it, and the second person will always receive 75%. Okay, so I hope this was clear. Now, let's take a look at some examples. So some chocolates are shared between Charlie and Dave in the ratio 9 to 6, respectively. Now being asked to simplify this ratio. Okay, so part A, I'll go ahead and write the ratio down. Now we have 9 and 6. We need the highest common factor among them, which is dividing by 3 gives us 3 to 2. Okay, so that's it. This is the simplified ratio. Now for part B, find the fraction of the chocolates. So we want the fraction of the chocolates that each person receives. Give your answer in simplest form. Okay, so we want the fraction of the chocolates. Now I want you to notice we don't know the number of chocolates. We just know some chocolates, could be any amount. But we don't need the number of chocolates to know the fraction that each person will receive. Okay, now the way we do this is, again, we have 9 parts to 6 parts. So now the question is, what is the total parts? We get that by adding 9 plus 6, which gives us 15. This is the total parts. Sometimes they're referred to as shares as well, total shares or parts, okay? But I prefer parts. Now 9 plus 6 is 15. Now the first person, who's basically Charlie receives the 9, okay? And Dave receives the 6. Because they're in order, because we said respectively here. So for Charlie, the fraction that he will receive will be his number of parts, which are 9, divided by his the total amount of parts, which is 15. Okay, so this is the fraction he receives. That's it. But we just need to further simplify it. You can plug it on the calculator or just simply divide by 3 on the top and the bottom. And the simplified fraction is 3 over 5. Okay, and this is the final fraction that Charlie will receive, 3/5. Now, as for Dave, well, Dave has 6 parts out of a total of 15 parts. Okay, and again, if you go ahead and divide the top and the bottom by 3, we get 2 over 5. So Dave gets 2/5. Okay, and that's it. This is the fraction of the chocolates that Dave receives. This is the fraction of the chocolates that Charlie receives. So it's really important to note that we did not need to know the number of chocolates. Okay, we only need to know the ratio. Let's take a look here. Some books are shared between Emma and Fiona in the ratio 10 to 15, respectively. Firstly, simplify this ratio. So again, we'll go ahead and write the ratio down, 10 and 15. And to simplify this, we divide by the highest common factor, which is 5. And this gives us 2 to 3. So this is the simplified ratio. I just realized, by the way, in this example, I accidentally used this ratio right here. Now, there was nothing wrong with it. Adding 9 plus 6 gives us 15, which later simplified to 3 over 5, 2 over 5. But I completely forgot that I already simplified the ratio here. If I had used 3 and 2, then I would get directly the answer as 3 over the whole parts, which is 5, and 2 over the whole parts, which is 5. This is Dave. And this is Charlie. Okay. So as you can see, when the ratio is already simplified, you get your fractions fully simplified as it is. Okay. But there's nothing wrong with what we did here. Okay. We just had an extra step of simplifying the fraction. Okay. So now to continue in this example, so we got 2 and 3. Now for part B, find the percentage of the books that each person receives. Now, we want to find the percentage. Now the trick to finding the percentage is firstly finding the fraction and then turning it into a percentage. Now, I'm going to use the simplified fraction, the simplified ratio, sorry, okay? 2 and ratio with 3. Now again, the total parts is 2 plus 3, which is equal to 5. Total parts. Now, for Emma, she receives 2 parts out of a whole of 5 parts. Okay, so 2 over 5. Now I'm going to go ahead and multiply this by 100 to get the answer as a percentage, which will give me 40%. Now, as for Fiona, she has 3 parts out of a possible 5 parts, and multiplying this by 100 gives us 60%. Okay, so this is Fiona's percentage, this is Emma's percentage. And again, we didn't need to know the number of books. Okay, we were just told some books. Okay, now you should try to solve these exercises on your own and then check the answer. I'm going to solve them really quickly now. So firstly, part A, simplify this ratio. So we have some muffins shared between George and Hannah in the ratio 18 to 24. I will go ahead and write the ratio. And now we want to simplify this ratio. So the highest common factor among those two numbers is 6. So we'll divide both sides by 6. We get 3 and 4. Okay. Like I've said before, if you're unsure what's the highest common factor, you can always just plug on the calculator 18 over 24. This will give you 3 over 4. So now you just have to think, how did the 18 become 3? And how did the 24 become 4? All that got obviously divided by 6. Okay? Now, part B. Find the fraction of the muffins that each person receives. Give your answer in the simplest form. Now, our ratio is 3 to 4. Once again, I will repeat this. It doesn't matter if you use 3 to 4 or 18 to 24 because they're the exact same. I'm simply using 3 to 4 because it's simplified. Now, I will add 3 plus 4 to find the total parts, which is 7. And so we can go ahead and write that George receives 3 parts out of an entire 7 parts. And this fraction doesn't have any further simplification. As for Hannah receives 4 parts right here out of a possible 7 whole parts. Okay, so 4 over 7, and that's it. This also does not have any further simplification. Okay, let's take a look at this example. A sum of money is shared between Kevin and Jack in the ratio 14 to 21, respectively. Part A, simplify this ratio. I will go ahead and write the ratio down, 14 to 21. And I will divide through by the highest common factor, which is 7. It gives us 2 to 3. Okay. Part B, we're being asked to find the percentage of the money that each person receives. Now, Kevin receives, so right here, Kevin and Jack. This 14 parts belong to Kevin, 21 parts belong to Jack. Now, right here, 2 to 3, this is just a simplified. I will use a simplified, obviously. Now, 2 plus 3 is equal to 5. This is the whole parts. So, firstly, for Kevin, he receives 2 over 5. Okay, because he received 2 parts out of a 5 total parts. Now, we want this as a percentage, so I will go ahead and multiply by 100, and we get 40%. And as for Jack, he receives 3 parts out of 5 whole parts, and multiply this by 100, and gives us 60%. Okay, so I hope this was clear. Okay, so now let's take a look at scenarios that you might come by in questions. Firstly, given an amount, share it into a ratio. Okay, so for example, what if you had $100 to divide among 2 people in the ratio 2 to 3? How can you find how much each person receives? Okay. Now, of course, logically speaking, if you, for example, had $5 divided among 2 people in the ratio 2 to 3, then the first person gets $2 and the second person gets $3. But this is easy because you only have $5. Now, what if we scaled it up to $100? So now we can see that the total amount of money is not equivalent to the total parts. Okay, in this case it was 5 parts, $5, which means each part is $1. But here we have $100 and 5 parts, okay? So the trick you're always looking for is to find how much one part represents, one part or one share, okay? If you find how much one part represents, then that's it. Okay, so this is like the the crown jewel. This is what you always want to look for. This is what you always want to find, okay? Now, how will we find how much one part represents? Well, now, firstly, step one is find the total parts. My ratio is 2 to 3. The total parts is going to be 2 plus 3, which is equal to 5. This is the total parts. All right. Now, step 2 is to actually find how much one part represents. Now, how will we do this? Well, I have $100 and I have 5 parts. So how much does each part represent? Well, we'll divide the 100 by 5 and it gives us $20, okay? So $20 is basically one part. So each part represents $20. The final step, which I will take over here, is to find how much each person receives. Because now I know how much one part represents. Every part represents $20. So for person A, don't forget the ratio is 2 to 3. For person A, he will receive 2 parts. So 2 parts, and each part represents $20. So I multiply by $20. And so he receives $40. Okay. As for person B, he receives 3 parts multiplied by $20 per part, which gives him $60. Okay. So that's it. This is what the first person receives. This is what the second person receives. Okay. So I hope it was clear. Now, another scenario you might come by is given one part of the ratio, find the other. So let's take a look here. So a cleaning solution is made by mixing detergent with water in the ratio 1 to 4. Okay. So it's important to trace. So 1 to 4. Okay. Now, detergent and water. So this right here is the detergent. This right here is the water. Okay. It's always good to mark your ratios so you can keep track. Okay. Now, if you have 6 liters of detergent, how much water needs to be added to make the solution? Okay. So what we have here isn't the total amount of liters. We have 6 liters of detergent, particularly. Okay, and we want to know how much water I need. Okay. So now here's the thing. You see, again, what you want to find is in this scenario, what does one part represent? Okay. Now the ratio is 1 to 4. And we have 6 liters of detergent. Now, which share is which part is the detergent? Well, it's D right here. It's 1. Okay. So in order to know how much does the detergent represent as a part, you divide the total detergent by the parts of the detergent. So in this case, it will actually just be 6 divided by 1, which is just 6. Okay. So basically what this says is that every part represents 6 liters. Okay. So now you have 4 parts for water. So how much water do I need? I need 4 multiplied by 4 parts multiplied by what each part represents, which is 6 liters. So 24 liters of water. Okay, that's it. Okay, let's take a look here. Now, sometimes you are given the difference in a ratio. In a garden, the ratio of rose bushes to tulip plants is 4 to 7. Okay, 4 to 7. And right here you have rose bushes and you have tulips over here. Given that there are 18 more tulip plants than rose bushes, how many total tulips and rose bushes does the garden have? Okay, so in this case, we know the difference. We know there is 18 more tulips, okay, than rose bushes. Now, don't forget, the end aim is to always find how much does one part represent, and then I can solve my problem, okay? So now let's see. Now we know that there is 18 more tulips. Now let's take a look here. We have 4 to 7. What is the difference between 4 and 7? It's 3. We get that by subtracting 7 minus 4, and we get 3. And it's 3 parts. Okay? So 7 minus 4 is 3 parts. And so this is the difference between the parts. Now, this difference right here, this 3-part difference, is actually 18 tulips. Okay? So I hope this was clear. So again, we have a difference in the actual amount of 18 tulips. The difference in parts is 3 parts. So 3 parts are represented by 18 tulips. So how can I find how much one part represents? I will divide 18 by 3, and we get 6. What does this mean? Well, one part represents 6 plants, basically, whether they're rose bushes or tulip plants. Now, in order to find the total tulips and rose bushes does the garden have, we will go ahead and write that we have 4 parts of rose bushes and multiply this by 6. And this gives us 24. So we have a total of 24 tulips. No, sorry. Of rose bushes. Okay. And also we have 7 parts. Okay. And multiplied by what each part represents, which is 6 plants. And this gives us 42 tulips. Okay, because the 7 parts are the tulip parts. So now the total number of tulips and rose bushes that I have, we would get that by adding 24 plus 42, which gives us 66 in total. Okay, I hope this was clear. Now let's take a look at some examples. So x is 1/3 of y. Work out the ratio of x to y. The easiest way to do this is to just simply write it out. So x is equal to 1/3, this is 1/3 of y. Okay. Now we multiply this by 3 to get rid of the fraction, so we get 3x is equal to y. And what this means is that every 3 x's, you have 1 y. So what is the ratio? It's 3 to 1. This is the ratio between x and y. Okay? So x to y is 3 to 1. This is the easiest and best ways to do this. Some students rush and just write out 1/3 of y, so 1 to 3. This is completely wrong. Okay? This is the right way to do it. And of course, 1 to 3 is not equivalent to 3 to 1. All right. Lena, Oscar, and Quinn share $720 in the ratio 6 to 4. Okay, so now we're dealing with a 3-part ratio, but the process does not change. Okay. How much money does each of them get? Okay. So now, again, what we want to find is what one part or one share represents, and then we can find everything else. So firstly, we'll write out the ratio, 6 to 4, and I will go ahead and find the total number of parts by adding them. So 6 plus 2 plus 4, and this gives us 12. By the way, you can simplify the ratio if you wanted, but the answer will still be the same, okay? Like this ratio can be divided by 2. It will simplify. But not without simplification, you will still get the correct answer. It's fine. Now, what I'm going to do is, now we know there's 12 parts or shares. Okay. So I want to know how much each part represents. I have a total of $720. So 720 divided by 12. Okay. You can go ahead and plug this on the calculator and it gives us 60. So each part represents $60. Okay. So now let's find out how much each person gets. So firstly, let's start with Lena. For Lena, she has 6 parts, okay, and each part is $60, so she gets $360. For Oscar, he has 2 parts, and each part is $60, so he gets $120. And finally, Quinn, 4 parts multiplied by $60 per part, and he gets $240. Okay, so that's it. This is the money divided amongst them based on the ratio that we were given. Okay. Now, a basketball team played 70 games. Each game was either a win, a tie, or a loss. Okay. The ratio of the number of games won to the number of games tied to the number of games lost is 5 to 3. Okay, so 5 to 2 to 3. This is win, this is tie, and this is lost. Work out how many more games the team won than the team lost. Okay, so it's important to understand what we want here. We want to know how many more games did we win than did we lose. Okay, now the way we do this is to firstly find how many times did we win, how many times did we lose, and subtract them. Now, in order to do that, again, we need to know what does the one part, how much one part represents. Now we have 5, 2, and 3. I will go ahead and add them. So 5 plus 2 plus 3, and this gives us 10. So we have 10 total parts. Now what are we dividing? We have a total of 70 games. So we'll go ahead and divide 70 by 10. This gives us 7. So each part represents 7 games. Okay. So how many games did we win? Well, 5 parts for winning, and each part is represented by 7 games. So we won 35 games. Now, how many parts did we lose? Well, 3 parts multiplied by each part is represented by 7 games, and so 21 games. So now what the question is asking for is the difference. He's asking for how many more games the team won than the team lost. 35 minus 21, we get 14 games. So we won 14 more games than we lost. Okay, I hope this was clear. There is another way of doing this, by the way. So instead of finding how many did we win and how many did we lose, we can simply look over here and say, what's the difference in parts between winning and losing? You have 5 wins, 5 parts for winning, 3 parts for losing. 5 minus 3 is 2 parts. So the difference is 2 parts, and each part is represented by 7 games, so 14 games, okay? So this is just another way of doing it, okay? It incorporates understanding how the parts are divided, okay? Right. Let's take a look at example 4. 4 companies sent some employees to a workshop. One of the companies sent both managers and staff. This company sent 12 managers. the ratio of the number of managers to staff it sent was 2 to 3. So I know that the ratio between managers and staff is 2 to 3 respectively. So this is the managers and 2 parts managers, 3 points staff. And I know that I sent 12 managers. There's supposed to be an A here. Okay. So this is basically scenario 2, where I know one of the parts. Okay. Now the other 3 companies sent only staff. Okay. Each of the 4 companies sent the same number of employees. Okay. So we know that all 4 companies sent the same number, but the other 3 sent only staff. Okay. The first one sent both managers and staff. Work out the total number of employees sent to the workshop by these 4 companies. Now, in order to figure this out, we need to understand that we have basically 4 companies, and each of them sent the same number. The same number of staff, except the first company. But in the end, they all sent the same number of employees, really. Okay? So to know the total number of employees, I would just need to know how much did each company send. Okay? Now we have a clue over here about one of the companies where we were told that the managers to staff ratio was 2 to 3 and we sent 12 managers. So we actually have the number of managers. Now we can use that in order to find the number, how much one part represents. Okay? So we have 12 managers, and the managers are represented by 2 parts. So 12 divided by 2, you get 6. So each part in this ratio is represented as 6 employees. Okay? So how much total employees do I have? Well, I'm going to have 2 times 6, which will give us 12, which is the managers. We were already told that, really. So you don't need to do this. But the other part is 3 times 6, which gives us 18 staff. Okay, so now I figured out this right here. This is what the first company sent. If you add those numbers, we get 30. So the first company sent 30 employees, managers, and staff. Okay. The other 3 companies sent only staff, but they all sent the same number of employees. So how many companies do we have? 4 companies. Each of them sent 30 employees because they all sent the same number, and the first one sent 30. So we get 120 employees in total. Yeah, so this should be clear. Okay, let's take a look here. Kevin, Sarah, and Mike share some money in the ratio 4, 3, and 5. The total amount of money that Sarah and Mike receive is $32. Work out the amount of money that Kevin receives. So this is my ratio, and 4 parts for Kevin, 3 parts for Sarah, and 5 parts for Mike. Okay? Now, we know the amount that was received by both Sarah and Mike. Okay? So be careful. Not just one person, 2 people received $32. Okay, so Sarah and Mike, they received $32. So this is basically scenario 2, where you know one of the parts, not the total amount of money, but you know the amount of money for one person. But in this case, you know it for 2 people, which is Sarah and Mike. So again, what I want to find is how much does one part represent? Now we know that Sarah and Mike got $32. Now, what are the parts for Sarah and Mike? Well, Sarah has 3 parts and Mike has 5 parts. Now, so 3 plus 5 is 8 parts. So 8 parts gave us $32. So what does 1 part give us? We divide the 32 by 8. We get $4. So $4 is represented by 1 part. So how much will Kevin receive? Well, Kevin has 4 parts. Multiplying this by $4, we get $16. Okay, and that's it. This is what Kevin receives. If you were asked what is the total amount of money, well, it's 16 plus 32. Okay, that would be the total amount of money shared because Sarah and Mike got $32 and Kevin got $16. Okay, moving on. Alice, Ben, and Charlie shared some marbles in the ratio 3 to 4 to 6. This is Alice, this is Ben, and this is Charlie. Now, Charlie got 12 more marbles than Alice. Work out the total number of marbles they shared. Okay, so this is scenario 3. We actually know the difference, okay, between the shares. Now, we know that Charlie got 12 more than Alice. I have 12 marbles. Now, let's take here, what is the difference in parts between Charlie and Alice? Charlie has 6 and Alice has 3. So 6 minus 3 gives us 3. So in the ratio, there is a 3-part difference between them. And that 3-part difference is 12 marbles. So again, what do I want to find? I want to find what does 1 part represent. This is always, as you notice, this is always the one thing that will solve all my problems. So how do I find that? I will divide 12 marbles by 3 parts and we get 4 marbles per part, basically, okay? So each part is represented by 4 marbles. So now, what is the total number of marbles? You can do this in 2 ways. I will do that in both ways, okay? The first way is to just find, okay, well, let's see how much Alice got, and Ben, and Charlie. Now for Alice, 3 parts, each part represented by 4, so 12. For Ben, 4 parts, each part represented by 4, so 16 marbles. And finally, for Charlie, 6 parts multiplied by 4 marbles per part is 24. And then your answer will be adding 12 plus 16 plus 24. And I'm going to go ahead and plug this on the calculator. We get 52 marbles. This is the total marbles that they shared. Okay. What about the other way? The other way involves you saying, okay, well, how many parts do I have? Well, the total number of parts is 3 plus 4 plus 6. Okay. And this gives you 13. And I'm like, okay, so I have 13 parts in total. And each part is represented by 4 marbles. So I have 52 marbles in total. Okay, so as you can see, this method, it is faster. It does involve a lot less writing. But you can use either. Either way is correct. Okay, now let's take a look at some exercises. You should pause the video and try to solve the exercise and then check your solution. So, let's take a look here. Z is half of X. Work out the ratio of Z to X. So like I said, translate this into equations. So Z is equal to half of X. And then I'm going to go ahead and multiply by 2 to get rid of the denominator. I get 2Z is equal to X. So every 2 of Z is 1X. Okay? So the ratio between Z and X is 2 to 1. And that is it. This is the answer. Move on to the next one. John, Emily, and Michael shared some candies in the ratio 3, 6, and 8. So 3, 6, and 8 shared among John, Emily, and Michael. Michael got 15 more candies than John. So we know the difference between the shares or the parts. Okay, this is a scenario. I don't remember, I think it was scenario 3, but the point is that we know the difference, okay? So 15 candies. Now we need to work out the total number of candies they shared. To know the total number of candies, firstly, I need to know what does one part of candy represent, okay? We have 15 candies that Michael got more than John. So let's take a look here. This is Michael, this is John. What is the difference between their parts? 8 minus 3, which is 5 parts. Now, this 5-part difference gave you 15 candies. So what does one part represent? I'll divide 15 by 5. We'll get 3. So 3 candies per part, basically. Okay. So now what is the total number of candies? Like I've said in the example, you can either multiply 3 by 3 and then 6 by 3 and then 8 by 3 and add them, or simply add all the parts. So 3 plus 6 plus 8, which is 17. And then multiply the total parts by what does each part represent. And this will give you 51 candies, okay? This is the total number. Now again, if you wanted to do 3 parts times 3 candy per part, give you 9, and then 6 times 3 will give you 18, and then 8 times 3 will give you 24. Add all those numbers, you will also get 51, okay? And it's a valid method, it works. Okay, question 3. Work out the difference between the largest share and the smallest share when 2,760 is divided in the ratio 3 to 5 to 9. So this is an interesting application here. I want to know the difference in shares when I divide this amount of money by this ratio. Now, easiest way to do this is to find each share and then subtract them. Okay, so we have 3, 5, 9. Now, the total parts is 9 plus 5 plus 3, which will give us 17 parts. And the total amount of money that I'm dividing is 2,760. Dividing this by 17, I'm going to go ahead and plug this on the calculator. Okay, so it's not going to be an accurate answer. So I will be working with a fraction for now, okay, which is 2,760 divided by 17. Okay. This is approximately $162. Okay. But I will continue to use the accurate form for now. Okay. Now we want to know the difference between the largest and the smallest share. Okay. Now there is multiple ways to do this. By the way, honestly, I want to change the number because it's not supposed to be this way. See, I write the examples myself. Sometimes I accidentally choose numbers that might make it unrealistic because you're not supposed to work with this that way. Okay, so we're going to change the total amount of money to 1,020. Okay, so now I will divide 1,020 by 17. Okay, and this gives us $60. Okay, so I have $60 per part. Now, we want to know the difference between the largest share and the smallest share. So, as you can look here, what is the largest share? It's the person who's going to get 9 parts. And the smallest share is the person who's going to get 3 parts. Now, the person who's going to get 9 parts is going to get 9 times $60 per part. Okay? And this will give us $540. This is his share. Now, the person that will get 3 parts times 60, he will get $180. Okay? This is his share. So what is the difference between their shares? It will be 540 minus 180 and gives us $360. This is the difference. Okay? There is another way of doing this. The other way is to firstly subtract the shares. Okay, so I'm like, okay, so I have 9 shares or 9 parts and 3 parts. So 9 minus 3 is 6 parts. This right here is the difference in parts. This difference, when I multiply it by what each part represents, which is 60, it will also give me $360, okay? So again, you cannot always have 2 ways to do these kinds of problems. Okay. Alice, Brian, and Claire shared some money in the ratio 6, 9, 13. So 6, 9, and 13. And again, we have A, B, C. Alice and Brian received in total $90 more than Claire. Work out the amount of money that they shared. Now we need to understand here that we have 90 more received by Alice and Brian. $90 more. This right here, this is not what they received. This is the difference between Alice and Brian and Claire. So if you put Alice and Brian's money together, it will be 90 more than Claire. Okay? So how will we do this? Well, we know it's $90 more, but in terms of these parts, what does the $90 represent from these parts? Well, Alice's parts plus Claire's, not Claire, plus Brian's part is 6 plus 9, which is 15. So both of them together have a total of 15 parts. Now, what is the difference between them both together and Claire? In the money, it's $90. In terms of parts, it's 15 parts for both Alice and Brian, minus 13 parts for Claire. So the difference is actually 2 parts. Okay? Those 2 parts were represented by a total of $90. So can I find what does 1 part represent? Yes. I divide $90 by the 2 parts. And it gives us $45. Okay? So what is the total amount of money they shared? I will just simply go ahead and add all of their shares. So it's going to be 6 plus 9 plus 13. And this will give us 28. And now I will multiply 28 parts, and each part is $45. And this gives us $1,260. Okay, this is the total amount they shared. Once again, you can do this by multiplying 6 by 45, 9 by 45, 13 by 45, and then adding them. Both methods work. You will get the same answer. Okay, let's take a look at our final exercise for this video. Lucas, Mia, and Noah share some money in the ratios 4, 3, and 7. The total amount of money that Mia and Noah receive is 90 more than the amount of money that Lucas receives. Okay, so we have 4, 3, and 7 shared among Lucas, Mia, and Noah. And both Mia and Noah received 90 more than Lucas. Now, we're told here that Lucas buys a book for 35.75 with some of his share money. Work out how much money Lucas has left from his share after buying the book. So the way we solve this is, firstly, let's find out how much money did Lucas have in the first place from sharing the money, okay? And then through that, we'll find out how much money he has later. Now, this is very similar to the previous exercise. We know that both Mia and Noah had 90 more than Lucas. Now, Mia and Noah's parts are 3 plus 7, which are 10 parts. The difference between both Mia and Noah and Lucas is 10 minus 4, so it's a 6-part difference. This 6-part difference was basically $90 more. Okay, so how am I supposed to find how much each part represents? Well, I will divide the 90, which is the difference in money, by 6, which is the difference in parts, and this gives us $15. So each part represents $15. Now that I've figured this out, I can know how much did Lucas receive from sharing the money, which will be 4 times 15, because he has 4 shares. Now this gives us $60. All right. Now we know that Lucas bought a book for 35.75. Now how much does he have left? Well, 60 minus 35.75. So I subtracted the price of the book from the share money that he received. Okay, and so we get our final answer that he has $24.25 left. Okay, I hope this was clear, and thank you for watching.